Miles Bughaw, kindly please lead the prayer.
Yeah, for the Catholics, kay ikaw ang pagsanod the cross na mo. So, let us pray. Dear God, thank you for this beautiful day. Thank you for being with us always. I ask thee for you to provide us with the knowledge and wisdom to understand our lesson and protect us from all harm and danger. And all this I ask in the loving name of Jesus we pray. Amen.
Thank you. Good morning, class.
Morning, ma'am.
Morning, ma'am. Ma'am.
So last meeting, we have travel or we have discussed about the desert. So basically, there are 4 types of desert. Ay, wait na. So okay ra ba ninyo nga mag-on ko, mag-off cam ko?
Okay, ma'am.
Okay, so excuse me. Nasaan na ba ta? So last meeting, we have discussed about deserts. Basically, there are 4 types of deserts. So what are those? Can someone give me the 4 types of desert?
Ang 4 types of desert, ma'am, kay subtropical, coastal, cold winter, and polar.
Very good. So who among you didn't know that uh polar regions have desert? Before na discuss ang about sa desert. Raise your hand. Kabalo. Okay, so I myself didn't know that there are 4 types of desert there. Kasi we only knew the subtropical desert kay mao man na ang pinaka common, and we knew that desert is hot and it has a lots of suns, no? So dili kita familiar sa polar desert. So in polar desert, it has a climate of cold year round, no? So unsa may makit-an sa polar desert di ay? What can we see in a polar desert kay? Anyone, unsay naa sa polar desert or sa polar regions far earth?
Ice or glaciers, ma'am.
Uh, yes, very good. So glaciers or ice. So what are those glaciers, by the way? So today we are going to discuss about glaciers. So what are glaciers? The term glaciers comes from the French word glacier, which means ice. So glaciers often called rivers of ice. Glaciers are a large perennial accumulation of crystalline ice, snow, rock, sediment, and often liquid water that originates on land and moves down slope under the influence of its own weight and gravity. So, ang glaciers kay dili lang di ay ice, no? It also have the presence of rock, sediment, and liquid water. So massive ice sheets covered much of North America and Europe during the Pleistocene time period. So this was the last glacial period, also known as the Ice Age. Ice sheets reach their greatest size about 18,000 years ago. So as the ancient glaciers spread, they carved and changed the Earth's surface, creating many landscapes that exist today. During the Pleistocene Ice Age, nearly one third of the Earth's land was covered by glaciers. Today, about one tenth of Earth's land is covered by glacial ice. So imagine no, dagko kayong difference sa Pleistocene Ice Age compare karon kay almost of the glaciers have melted and only one tenth of Earth's land is covered with glacial ice. So now we go to the types of glaciers. Primarily, there are two types of glaciers. We have the alpine or mountain glaciers and the continental glaciers. So in under the alpine or mountain glaciers, we have the cirque glaciers, the valley glaciers, the fjord glaciers, the pediment glaciers, and the ice cap. And then the continental glaciers, we have the ice shelves. So mauni no, so alpine glaciers is glaciers found on mountains or mountain range or valleys. On the other hand, the continental glaciers is uh is the glacier that we see that covers uh the underlying terrains. You see this example. So alpine glaciers is a glaciers in mountain that flow down valleys is called an alpine glacier. So those glaciers that you can see in the mountain range are called alpine glaciers. Now if a glacier is formed on a step walled basin of a mountain, we call it the cirque glaciers. Cirque glaciers is the smallest type of glaciers that are confined in a valley and forms in a cirque, or a cirque is a semicircular basin at head of valley formed by plucking of bedrock by a glacier moving downhill. Next is we have the valley glaciers. So these valley glaciers is the glaciers that are confined to a valley. So usually it forms streams, no? So now if this valley glaciers extends down or flows down to sea level, it may carve a narrow valley into the coastline. So the narrow valleys they have carved and later become filled with seawater after the ice has melted are what we call the fjord glaciers. Or if valley glaciers haven't extend to sea level and those valleys keeps moving and they met and merge at a base of a mountain, we call it the pediment glaciers. So pediment glaciers is the when two when two glaciers meet and merge at the base of a mountain. So now if these pediment glaciers na pod, if these pediment glaciers flows to the sea, soon we call it the tidewater glaciers. So unsay difference sa tidewater o sa fjord glaciers? So fjord glaciers is a glaciers from a valley that flows down to the sea. So that flows to the sea or that extends to the sea. And the tidewater glaciers is a pediment glaciers that flows to the sea. Um, if all the valleys in a mountain range become filled with glaciers and the glaciers cover the entire mountain range, we call it the ice cap. So, mauna ni ang, for example, ani kay kani see the picture. So, na-cover niya ang entire mountain range. So, an ice caps are an ice mass that covers less than 50,000 kilometers squared. So, above the 50,000 kilometers squared ice mass that covers a mountain range is what we call the continental glaciers. So, continental glaciers is the largest types of glaciers on Earth. Excuse me. So, they cover large areas of the land surface, including mountain areas. So, it is found only in Greenland and Antarctica. So, wala ni siya nag-exist sa Arctic region or other polar region of the Earth. So now we go to the ice shelves. So ice shelves are sheets of ice floating on water and attached to land. So they usually occupy coastal environments and may extend hundreds of kilometers from land and reach thickness of 1,000 meters. So ice from enormous ice sheets slowly oozes into the sea through glaciers and ice streams. If the ocean is cold enough, that newly arrived ice doesn't melt away. Instead, it may float on the surface and grow larger as glacial ice behind it continues to flow into the sea. So along protected coastlines, the resulting ice shelves can survive for thousands of years, bolstered by the rock of peninsulas and islands. Ice shelves grow when they gain ice from land and occasionally shrink when icebergs gulf off their edges. So this gives and takes helps them maintain a dynamic stability. We have this temperate and the polar glaciers. So what is temperate glaciers? Temperate glaciers are also called the isothermal glaciers because they exist at the uh, pressure melting point. So the melting temperature of ice is at given pressure to throughout their mass. On the other hand, the polar glaciers is the opposite of the temperate glaciers. And the ice in polar or cold glaciers is below the pressure melting point. I have here the example of temperate glaciers. I sorry. And we have here the polar glaciers. So how do glaciers form? So glaciers begin forming in places where more snow piles up each year than melts. Soon after falling, the snow begins to compress or become denser and tightly packed. It slowly changes from light, fluffy crystals to hard, round ice pellets, and then new snowfall falls and buries the granular snow. So glacier form from the snowflake to the granular snow. Then it become firm and it become glacier ice. So how do a glacier change its size? So a glacier can change its size by accumulation, which occurs by addition of snowfall, compaction, and crystallization, and ablation, the loss of mass resulting from melting, usually at lower altitude where temperature may rise above freezing point in summer. So we have here the accumulation and the ablation zone, the two zone of glacier anatomy. So in accumulation zone is a region where snowpack or superimposed ice accumulation persists. So in ablation zone is the region where all of the snow has melted away and bare glacier ice is exposed. So diri na punta sa glacial movement. So let us know how do accumulation and ablation affect the movement of glaciers. So glacier advance if accumulation is greater than ablation, then the glacial ice two advances. So when accumulation is less than ablution, glacial 2 retreats upslope. Can you follow? So, kung ang accumulation is mas dagko kaysa sa ablution, so ang glacial 2 mo advance. However, if the accumulation is less than the ablution, so ang glacial 2 retreats upslope. And we have the two types of glacial movement. So, like the slow forms of mass wasting, we normally cannot view glacier movement directly. Nevertheless, flowing ice has a tremendous geomorphic impact on the landscape. Most glaciers move through a combination of processes, but internal plastic deformation is the dominant process. Virtually all moving glaciers experience this type of flow. Glacier move to lower elevation under the force of gravity by the two different process which we will discuss after these slides. So let us see first how the difference between the glacial movement of the valley glaciers and the continental glaciers. So in the first picture, it has one way of moving. On the second picture is the example of continental glaciers. So it has different way of moving or flowing. Now we have the internal flow or deformation. So It is result from the formation of the ice crystal structure. The crystal slides over each other like a deck of cards. So this is how glacier moves by internal flow or deformation. So this type of movement is the only type that occurs in polar glaciers, but it also occurs in temperate glaciers. The upper portions of glaciers are brittle. When the lower portion deforms by internal flow, the upper portion may fracture due to for may fracture to form large cracks called crevasses. On the other hand, we have here the example, and we have the basal sliding. So basal sliding is the melt water at base of glacier reduces friction by lubricating the surface and allowing the glacier to slide across its bed. So basal sliding is polar glaciers usually frozen to their bed and are those too cold for this mechanism to occur. So wala na siya nag-exist sa polar glaciers, no? So glacier can slide because ice melts under pressure. So it resulting in a film of water at the ice bed interface. So this can facilitate decoupling and enhance fast ice flow. If the glacier's bed is rough with many bumps and obstacles, this increases melting and ice flow. Now we go to the equilibrium and the glacial budget. So between the two zones, the accumulation in the zone of accumulation and the zone of ablation is the line of equilibrium, which is the point at which inputs and outputs are balanced. So during winter or colder climatic periods, the equilibrium line falls further down the glacier and occurs higher up in summer or warmer periods. If ablation outpaces accumulation, mass balance is negative and a glacier will shrink. If the two processes result in no net gain or loss of snow and ice, the balance is zero and the glacier is in equilibrium. So, simply stating, equilibrium is a balanced state with no net gain or loss. On the other hand, we have the glacial budget refers to the balance between the amount of inputs versus outputs affecting the glacial system. So a glacial budget is the total amount of accumulation in ablation for a glacier. If ablation exceeds accumulation, then the glacier will melt. If accumulation exceeds ablation in the glacier extend mo akong giingon gaina about the how accumulation and ablation affect the glacial movement. So the glacial budget describes how ice accumulates and melts on a glacier, which ultimately determines whether a glacier advances or retreats. A glacier behavior depends on the balance between accumulation and excuse me, wastage or melting. Now we have here the glaciation. The process of glacier growth and establishment is called the glaciation. Glaciers shape the land through the processes of erosion, weathering, transportation, and deposition, creating distinct landforms. So in glacial erosion, we have the small scale erosional features. We have the glacial striations. Glacial striations is along parallel scratches and grooves that are produced at the bottom of temperatured glaciers by rock embedded in the ice scraping and against the rock underlying the glacier. Linear scratches, grooves, and excuse me. Glacial striations or stray are scratches or grooves cut into bedrock by glacial abrasion. So unsay makita ba ang picture?
Yes, ma'am.
Unsa nga types of weathering ang nahitabo dira based on the weathering of rocks?
Physical, ma'am.
Yes, physical weathering. So nagkaroon ng mga scratches, no?
Yes, ma'am.
Now we have the glacial polish. Rocks that has a smooth surface produced as a result of fine-grained material embedded in the glacier acting like sandpaper on the underlying surface. So kana nga kung sa kuan na physical weathering of rocks unsa na nga type based on the picture ang glacial polish. What types of weathering ang nahitabo dira? Can you see the picture?
Yes, ma'am.
So unsa na nga unsa yung nahitabo dira? So sa physical weathering kay nag-exfoliate siya, no? Can you remember about the exfoliation?
Yes, ma'am.
'Di ba kay pareho sila? So now we have the glacial erosions or the landforms produced by erosion of mountain glaciers. We have the cirques, glacial valleys, arates, the horn, the hanging valleys, the fjord, and the Rouge Mutni. So unsa gani lang si cirques? So walay makatubag.
Kuan, ma'am. Mura siya, mas gamay pa siya sa Valley Glaciers ang Cirques Glaciers, ma'am. Yun. Naada siya sa Valley siya makitaan, ma'am.
Okay, so cirques is a bowl-shaped depression that occurs at the heads of mountain glaciers. Yeah, tama. Excuse me, Saha. In glacial valleys, as we discussed a while ago, is glaciers form in valleys. No, so in arids, if two adjacent valleys are filled with glacial ice, the ridges between the valleys can be carved into a sharp knife edge ridge called an arid. So in horns where three or more cirques are carved out of a mountain, so they can produce a sharp peak called a horn. Sa hanging valley, when a glacier occupying a smaller tributary valley meets the larger valley, the tributary glacier usually does not have the ability to erode its base to the floor of the main valley. Thus, when the glacial ice melts, the floor of the tributary valley hangs above the floor of the main valley and is called a hanging valley. So waterfalls generally occur where the hanging valley meets the main valley. In fjord are narrow inlets along the seacoast that were once occupied by a valley glaciers. And we have the roche motne as asymmetric bedrock hills or knobs that are smoothly rounded on the up ice side by abrasion with plucking evident on the abrupt down ice side. We have here the examples, cirques. Makitan bang picture? Maklaro ninyo?
Yes, ma'am.
And we have the glacial valley and the arid and the horn. So, ang horn kay mura siya sa kuan. Karang pinaka-peak na sa mountain range bitaw. And then the hanging valleys. And we have the fjord and the Rouge Mutne. Now we go to the landforms produced by ice caps and ice sheets. We have the abrasional features, small scale abrasional features such as striation are glacial polish can occur beneath ice caps and ice sheets, particularly in temperate environments. Streamline forms the land surface beneath a moving continental ice sheet can be molded into smooth, elongated forms called drum lanes. So, mauni ang sa drum lanes. Mauni ang sa drum lanes. Picture. We have the glacial transportation. So glacier moves very slowly. So as they move, they transport material from one place to another. As freeze, so weathering occurs along the edge of the glacier, pieces of rock which break off larger rocks fall onto the glaciers and are, and are transported. So now we go to the glacial deposits. So since glaciers are solid, they can transport all sizes of sediments. Out akong giingon about about the glacial transportation. So from huge house-sized boulders to fine-grained clay-sized materials. The glacier can carry this material on its surface or embedded within it. Those sediment transportation in a glacier is very much different than that in a stream. Those sediments deposited directly from melting of a glacier can range from very poorly sorted to better sorted, depending on how much water transport takes place after the ice melts. All sediment deposited as a result of glacial erosion is the glacial drift. We have here the some examples of glacial deposits: the ice lid deposits, the till, the erratics, the moraines, uh, ground moraines, in moraines, and terminal moraines, the lateral moraines, the medial moraines, and the glacial marine drift, the drum lanes, then the stratified drift, the outwash plains, the outwash terraces, the kettle lakes, the cames and came terraces. Then we have the eskers. So see this illustration. So a till is a non-sorted glacial drift deposited directly from ice. Till consists of a random mixture of different sized fragments of angular rocks in a matrix of fine-grained sand to clay-sized fragments that were produced by abrasion within the glaciers. This fine-grained material is often called a rock flour because it is really ground up rock. So a till that has undergone diagenesis and has turned into a rock is called a tillite. Erratics naman kay a glacially deposited rock or fragment that now raised on a surface made of different rocks. The erratics are often found many kilometers from their source. And mapping by the distribution pattern of erratics, geologists can often determine the flow direction of the ice that carried them to their present location. Moraines are deposit of till that have a form different from the underlying bedrock depending on where it formed in relation to the glacial moraines. In relation to the glacier moraines, we have the ground moraines. So these are deposited beneath the glacier and result in a hammocky topography with lots of enclosed small basins. And we have the end moraines. We have the ground moraines. So these are deposited. We have the ground moraines. These are deposited beneath the glacier and result in a hammocky topography with lots of enclosed small basins. Then we have the end moraines and terminal moraines. So these are deposited at the low elevation end of a glacier as the ice retreats due to ablation. And then we have the lateral moraines are deposited of till that were deposited along the sides of mountain glaciers. And then we have the medial moraines when two valleys glacier meet to form a larger glacier. The rock debris along the sides of both glacier merge to form a medial moraine. So these black streaks in an active glacier as well as the deposits left behind after the ice melts are called the medial moraines. Then the glacial marine drift. Glacier that can reach ocean or even lakes may calc off into a large icebergs which then float on the water surface until they melt. Upon melting, the rock debris that they contain becomes immediately deposited in the seafloor or lake bed as an unsorted chaotic deposit. Sometimes single large rock fragments fall out on the floor of water body, and these are called the drop stones. So in drum lanes, so glacial retreats, leaving behind a terminal moraine. Later, it advances again and reshapes the moraines into drum lanes. Stratified drift, we have the glacial drift can be picked up and moved by water streams in which can then deposit that material is stratified drift. And the outwash plains. Streams running off the end of a melting glacier are usually choked with sediment and form braided streams which deposit poorly sorted um, stratified sediment in an outwash. Um, the outwash terrace, if the outwash streams cut down into their outwash deposits, the banks from river terrace called outwash terrace. So I will not discuss the others. You can just read it on your module kay kuan basin dili ta makaabot sa time. You see this illustration? We have the moraines. Now we go to the glacial ages. So glacial ages have long term and the short term variation. So long term variation is in climate tens of million years on a single continent are likely caused by drifting continents. If a continent drifts toward the equator, the climate will become warmer. If the continent drifts toward the poles, glaciation, excuse me, nawala. Sorry. Come on. Ayun. So, asan na ba ko? So, sa long-term variation on a single continent are likely caused by drifting continents. So if a continent drifts toward the equator, the climate will become warmer. If the continent drifts toward the poles, glaciation can occur on that continent. So short-term variations in climate are likely controlled by the amount of solar radiation reaching the Earth. Among these are astronomical factor and the atmospheric factor. So I have here the illustration. On the first illustration of Earth is the 18,000 years before present. And then the second is the modern day. So, unsay difference sa duha? Kanang white dira kay white um, color is the continental ice or the yes, continental ice. In the blue color is the sea ice. So unsay difference between the two? Maklaro ba ninyo ang picture?
Yes, ma'am.
Unsay difference? Unsay na usab or unsay kuan between between then and now? Between 18,000 years ago and karon nga modern day. Kung sa inyong na-observe,
Nag-melt ang ice mo?
Yes. So nagmelt ang ice or ni ano sa to'y answer so ni ang sa 18,000 years ago kay mas dagko ang portion sa continental ice. So karon kay gamay na ang continental ice nga na-cover sa atong earth. It is because of the unsa kahay kuan reason ani what causes these changes. So we have here the causes of glacial ages, the atmospheric fracture. So a century ago, Serbian scientist Milutin Milankovic hypothesized the long-term collective effect of changes in Earth's position relative to the sun are a strong driver of Earth's long-term climate and are responsible for triggering the beginning and end of glaciation periods of or the ice age. So in the atmospheric factors, the heat-trapping gases, sometimes called greenhouse gases, are the cause of most of the climate warming and glacial retreat in the past 50 years. And then the changes in oceanic circulation. Small changes in ocean circulation can amplify small changes in temperatures, variation produced by astronomical factors. And we have the other factors. The energy output from the sun may fluctuate. Then we have also the large explosive volcanic eruption can add significant quantities of dust to the atmosphere, reflecting solar radiation and result in global cooling. So all in all, we can say that so karon kay we can say that global warming or the climate change is the cause of the melting of the glaciers. So how do glaciers affect life on Earth? The glaciers melting water provides many regions with fresh drinking water. They create homes and habitats for many organisms in our animal kingdom. The meltwater, aka rundown of glacier water, provides energy resources to certain countries. They also provide water to desert regions. They are also natural resources, and people all over the world use the melted water that glaciers produce. People living in arid climates near mountain often rely on glacial melt for their water for part of the year. Farmers have also irrigated their crops for hundreds of years by channeling melted water from glaciers to their fields. So, mao to. So, that's the end of our discussion. If you have any question, you can ask now. Na may question?
Wala.
Wala na.
So, kung wala na may question, you can now go. And by the way, on yung 11 a.m. May man. 11 unya 11 a.m. Kuan mag-meet ta for your homeroom activity. We will have around 2 sa atong gibuhat last week. So you can now go.